What's up, math scholars and math haters? This is Mr. W. We are going to finish up probability with the fundamental counting principle. This is part 2 of a 2-part series. The other 2 examples I gave for this concept can be found in the part 1 video I made, which should have basically the same title as this. The people who make the kinds of problems for discrete math, especially when it comes to the fundamental counting principle, they love problems involving area codes or PIN numbers or that kind of thing. That's why I did the problem about the passcode in the first fundamental counting principle video that I did, and it's why I'm coming back to area codes now. So area codes and phone numbers are 3 digits long. So for instance, 202 or 484 or something like that. And the only restriction is that the first digit cannot be 0 or 1. And we're supposed to find the probability of picking area codes with different restrictions. So let's start by figuring out the total number of possible area codes. If the first digit can't be 0 or 1, that means it can be 2, 3, 4, 5, 6, 7, 8, or 9, which means that the first digit has 8 possibilities. The second digit and third digit don't have any restrictions on them to begin with, so they each have 10 choices. And 8 times 10 times 10 gives us 800 possible area codes. And now, you'll see that when we're just dealing with digits, we can make the problems a little trickier, like for instance, the probability of one digit or more digits being even, or odd, or less than 6, or something like that. But the idea is the same. We're just going to figure out what restrictions we have and go from there. So, we'll start with the probability that we get an area code with 2 as the first digit. Now, there were 8 possibilities for the first digit, but now there's just 1. We only are interested in the number 2 as our first digit. And that's 1 times 10 times 10 gives us 100 possible area codes that have 2 as the first digit out of a total of 800. And 100 over 800 is 0.125, so there's your probability for that one. Now, if we need 2 to be the second digit, it gets a little different because now we have no restrictions on the first digit. So there's still 8 possibilities for that. Now that I want 2 to be my second digit, there's just 1 possibility for the second digit. And then here's a possibility, and then for the third digit, there are no restrictions, so that's all 10. So we still have all 10 possibilities there. And 8 times 1 times 10 is 80 out of 800 total possible area codes. And this is just 0.1 or 1/10. Now, it gets a little trickier when we see if, for instance, the first digit is even. So if the first digit is even, there are 8 possibilities, can't be 0 or 1. Let me actually go ahead and write those over here. For that first digit, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Nope, not the 1. 9. So the first digit can be 2 through 9, and I wrote these numbers like this, specifically because this bottom row contains all the even numbers. So that means there are 1, 2, 3, 4 possible digits for that first one. And we have no restrictions on the second or third digit, so that's still 10 choices for the second digit and 10 choices for the third digit. Gives us 400 total possibilities for an area code where the first digit is even out of 800 total. And that's just 1/2 or 0.5. So now the second digit is less than 6. Now coming over to the second digit, we can have a 1 and we can have a 0 now. And if the second digit is less than 6, that means it can be 1, 2, 3, 4, 5, and also 0. We can include 0 in that, which means that there are 6 possibilities for the second digit. And then we need to look at our first and third digits to see if we have any restrictions there. For the first digit, we have no restrictions. There's still 8 possibilities. For the third digit, there were 10 possibilities there, which means that we're going to multiply our 8 choices for the first digit, our now 6 choices for the second digit, and our 10 choices for the third digit to get the total number of possible area codes where the second digit is less than 6, and that is 480. That's still divided by 800. which should give us an answer of 0.6 or 6/10. And now we come here to where all digits are odd. So now we're looking at all digits. For that first digit, it can be anywhere from 2 to 9. There's 1, 2, 3, 4 possibilities for an odd digit in the first space. There were 10 original possibilities for our digit in the second space. Since we're just looking for an odd one, that's 5. Same thing for the third digit. There's now 5 possibilities there. And now we're going to multiply 4 times 5 times 5 to get 100 out of 800, which, just like where we were looking for 2 to be the first digit, that's just 0.125. So now for our very last example for this video, we're looking for the probability of picking an area code where all digits are less than 6. Now for this first digit, it can't be 0 or 1, so our possibilities of a digit less than 6 for this first spot are 2, 3, 4, and 5. Means there's 4 possibilities there. For the second and third digits, we can have 0 or 1, which means it can be 0, 1, 2, 3, 4, or 5, meaning that there are 6 possibilities for the second digit and 6 possibilities for the third digit. So we multiply 4 times 6 times 6. That gets us 144 out of 800. And let me grab my calculator one last time for this. And that is exactly 0.18 or 1800ths. Now, I know a lot of these examples probably seem very confusing, especially this one with the area codes, but I just wanted to highlight how the process is the exact same no matter what our problem is. We're going to use the fundamental counting principle with the restrictions that a problem gives us to find the total possibilities for any, for instance, an area code with 2 as the first digit instead of any area code, and that kind of thing. We find those possibilities, divide by the total possible outcomes, and we use that to find our probability. And I also wanted to pick some relatively simple numbers to deal with here, just to avoid that bit of confusion, having to write a decimal that went on and on forever. It didn't seem like it was going to repeat until 20 or so places in. So that's it for the fundamental counting principle as it applies to probability. If you are my student, good luck on your assignment. If not, good luck on whatever work you're doing for this.